In this video, we'll be looking at the beta of CommonMap, a new software from XNimbus LLC. XNimbus is a funny name because it's Latin, meaning out of the cloud. We chose that name because we create deployable solutions for the warfighter that are as cool as the stuff from the cloud, just without all the cloud. One thing that we all associate with the cloud is web-based maps. Well, warfighters need maps too, and good maps are hard to find. NGA makes nice maps that are free, but the tools for them aren't so great. So CommonMap fixes this in a deployable manner by enabling NGA maps in existing tools using web map services. It deploys. You put it on a Windows laptop or even just run it from a hard drive. It saves money compared to commercial data by using free NGA data, and the software itself sells below FAR micro-purchase thresholds, so it's super easy to use, but it's also super easy to buy. Performs tasks thousands of times faster and yields web map services using global data sets. So you can use this again and again no matter where you go. And you can use it with whatever third-party software you want, so you can choose the right tool for the job, not just relying on ours. It indexes RPF, doesn't move it, doesn't copy it, doesn't convert it. 80,000 files per second, more than a terabyte per minute. 3,600 times faster than Esri or GDAL-based solutions. That creates a high-performance WMS that intrinsically understands RPF, shows the right data series at the right time. If there's holes in your data, it will show coarser imagery underneath it. If there's no appropriate coarser imagery to show, it'll show you a vector map. So there's always some sort of contextual map going on. And again, provides this as a WMS service to whatever GIS application you really need to use. Why did we pick RPF? Well, it's free. It's got excellent metadata. For instance, if I'm doing route planning and I see a bridge, I need to be able to look at the metadata of that imagery in order to decide, oh, this image is 10 days old or this image is 10 years old. What's my confidence that bridge is still there? Additionally, it's very small total data size, which means faster copying, faster deployment times, or just the ability to take more data with me. And we get to keep the data in its original resolution, and is really optimal for this use case. People usually say, well, I have this as RPF as a tile cache. Well, that tile cache took a lot of time to create, weeks or months. It probably passed through a lot of hands, and when you get it, it might actually be really stale data. You wouldn't know though, because this caching process destroys the imagery's intrinsic metadata. We no longer have that native metadata. We've resampled it, so we've introduced new artifacts, and that further limits the ability to perform any analysis upon that data. In addition, and this is one of the worst things, is that real world we see that those tile caches are about 3 times larger than the input RPF size. So you've duplicated your data and made it bigger. It's really not ideal. So if caching's not right, well, what's the other option? Well, you see that something like Esri, if I were to try to add all of the SIB1 corresponding to Russia to Esri using add raster to mosaic, for instance, that would take 90 hours. So the reason we haven't seen other tools use RPF effectively before is because they are not as fast as CommonMap. CommonMap does in 1 second what other tools take 1 hour to do. So let's go ahead and take a look at what this data looks like. Here we have a whole bunch of 1 kilobyte files that correspond to the naming conventions and the data conventions that would be the same for RPF. Now these aren't real RPF, and real RPF is limited distribution, so we can't show it to you. But we indexed all of those files, 20 million of them, in 4 minutes and 18 seconds. And we've ended up with this map. Now this is our vector-based map. This can be customized. We're going to show you these green rectangles as we zoom in. Here we have global navigation charts. If we zoom in again, we see jet navigation charts as well. We can see 2 different data sets at the same time because of that ability to show coarser imagery in the background. So we'll continue to see data sets as we zoom in here. The appropriate data set will show at the appropriate zoom level. So as we zoom in all the way, we see SIB1. And we get this same ability in third-party applications such as ArcMap or QGIS. So we can use this as a common operating picture background in whatever application we want. At the end, we have a dead simple tool for creating and sharing maps. It brings global scale mapping capabilities to all users using data and systems they already have, and we make that deployable. So you can have that background map context in your real mission critical tools so that they can deploy, because they often can't do it without that background map. Overall, big picture, in the time it takes to make a cup of coffee, you can index the world and have a deployable, shareable map that functions every bit as good as something like Google Maps. So, if you've got any questions, please visit our website or contact me. My name is Bill Thorpe, and thank you for listening.